we're going to start by actually trying to work with some identities now. I do want to tell you there are 3 other little identities I'm not going to hold you responsible for. The first 8 we just did are going to be extra credit option on your last quest. You have the option to write them, and you get extra credit points for doing those. Okay. There are 3 other little ones we don't use much, and for right now you're going to have to trust me on this until next year when I can prove it to you with some more, once we have some more knowledge. But there are a few rules about what to do when you have negative angles. Don't get excited about these. I will give these to you. I don't expect you to know them. Sine of a negative angle, turns out you can just pull the negative out front and it'll be the negative of the sine of the positive angle. Cosine, if it has a negative angle on it, is equal to the same thing as the cosine of the positive. There's no difference. And tangent also can have its negative pulled out front. Once again, those will make more sense next year when I can build some other topics in advance of the stuff we do in pre-calc the first semester before we start trig that will make that jive. But otherwise, for the moment, you just have to trust and believe me. Okay, what they want you to do is they want you to simplify these problems. The beauty of trig identities is that it lets you simplify complex expressions and make them simpler. That's the purpose. Okay, and our first one here, we have a cosecant of x times a tangent of x. You must write an angle in these. I don't care whether you put x's, thetas, a's, b's, whatever Greek letter floats your boat, you must have an angle at all times. I will take off points if you don't. Okay, what we want to do is we want to use our 8 fundamental identities, and we want to come up with a way to simplify this. In this case, we have 2 terms multiplied. We see no exponents, no squares, cubes, anything like that. So therefore, numbers 6, 7, and 8 are out. They only work with squares. We don't see anything here squared, so we are not using them at this point. Usually, your best method of attack is to change everything into sine or cosine. And you will notice that if you look at numbers 1 through 5, it turns every other trig function into a sine or a cosine. So we can take everything and change it into either a sine or a cosine. And that was what I would recommend here. So you would ask yourself, what do I know about cosecant of x? A single cosecant. And yes, I'm sure I heard somebody out there saying, hey, cosecant is 1 over sine. And that would be correct. 1 over the sine of x. Now, tangent, I also want to change into sines or cosines. And this is one you have to be aware of, because you've got 2 possibilities. Tangent could be a version of number 3, or it could be number 4. Use your common sense here, and a little bit of intuition. I have a 1 over sine. If I have a tangent, I want to change it into something that's also got sines and cosines. That would be number 4. So I would change this into sine over cosine, and then do the algebra. The sines cancel. If you ask yourself what's left, you have 1 over cosine. I consider that an acceptable answer. However, the book may go one step farther, and you'll notice that 1 over cosine of x is identity number 2. And so you can change 1 over cosine into secant. And so I would actually consider either one of those a simplified acceptable answer. Okay, second one. If you see any of them have a negative angle, immediately use those identities I just wrote in the top right corner and get rid of it. So I would change this one immediately. A negative angle on a tangent, it says pull the negative out front. So I would just throw the negative out in front of it all. Now, once I have that done, I need to change everything into sines and cosines. So you start asking yourself, what do I know about tangent? Well, yes, by number 4, tangent is sine over cosine. And if I do secant, I know secant is 1 over cosine, using number 2. So now it's algebra. You have 2 fractions that are divided. We all know that when you divide fractions, it means you really multiply by the reciprocal. So that's what I'm doing. I flip the cosine, the 1 over cosine, into cosine over 1. And oh look! The cosines cancel, and I have now simplified this expression down to a negative sine of x. Okay, our third example. We have secant of x squared minus tangent of x squared minus cosine of x squared. Okay, hopefully those squares are screaming at you, I'm squared, dude! Because if you have squares, most of the time you want to try to apply 6, 7, or 8 to them. So, obviously, nothing in 6, 7, or 8 has all three trig functions. But can you find a version of 6, 7, or 8 that has at least 2 of these in it? You have a secant, a tangent, and a cosine. If you go back and look, you will notice that, oh, looking at 6, 7, and 8 only, there's an identity that connects secants and tangents. In our case, our problem has secant squared minus tangent squared. So I could look at problem number 7 here and go, oh, if I subtracted the tangent over, I'd have secant squared minus tangent squared. And that would be equal to 1. So you can now go back to our problem here. Secant squared minus tangent here squared, that first chunk is 1. And you still have minus cosine squared left. Well, have you seen 1 minus cosine squared anywhere before? And yes, you'll notice up here on number 6 in pink, I wrote you the different versions of number 6, and there's one of them. 1 minus cosine squared is equal to sine squared. So we can now change this whole 1 minus cosine squared into sine squared. And you now have another simplified answer. So they're a lot of fun. It's kind of like solving a puzzle. You have to work out the puzzle pieces. Here's a couple more. Get a little exciting in places. This first one kind of lets me go, whoa, wait a minute. I got a tangent squared. I got a secant squared over a cosecant squared. Should I change them all to sines and cosines right now? Should I wait to change some of them? What should I do? So, in this case, I'm going secant squared over cosecant squared looks a little funky. I might hold off on that one for a minute, leave my tangent squared alone, figure out what on earth's going on here with the right-hand side of this thing. Now, the question is, what can I do with a secant squared and a cosecant squared? You don't want to use 6, 7, or 8 because you don't want to change secant squared into something that's got 2 terms and cotangent that's got 2 terms. Instead, you want to try to use numbers 1 through 5. What do you know about secant? And yes, number 2 says secant is equal to 1 over cosine squared. Cosecant squared says it's 1 over sine squared. So now, what happens, I have a fraction divided by a fraction. I'm going to multiply by sine squared over 1, in which case when I multiply the tops together I'll have sine squared, and the bottoms together I'll have cosine squared. And have we seen anything like that? Well, yeah, sine squared over cosine squared, that actually is tangent squared. So you've actually figured out that you have tangent squared minus tangent squared. Anything minus itself is 0. Are we having fun yet? Solving these is like solving a great puzzle. You just have to stick with it. Okay, this next one proves a big point. We know because of a sticky rotten crazy xylophone, you're going to get a lot of fractions with trig functions. So that's not a surprise. But if you're going to get fractions, you're going to have to do common denominators. And if you wanted to add these two together, you need to make a common denominator. So you would ask yourself, what would be in common to a sine x and a 1 plus cosine x? Well, since they're two totally different things, you would need both of them in your common denominator. Just be sure you keep your parentheses for the second one, since it's a quantity. Now, ask yourself, what is the first fraction missing? In order to have this common denominator, what does it need to be multiplied by? Well, yep, it needs to be multiplied by 1 plus cosine. Okay, on the top then, you will need to distribute cosine to both parts, which is going to give you cosine of x plus cosine of squared x. I distributed the cosine times each one. The bottom already has the common denominator. I don't have to do anything. Okay, the second fraction is missing what in the common denominator? And you're right, it's missing a sign. So I would multiply both top and bottom of it, on it by sine, which for the numerator, that'll make it plus sine squared. For the denominator, it's sine times 1 plus cosine. Now, why didn't I distribute the sine through the 1 plus cosine? You're hoping something's going to cancel. So don't distribute it if you can't help it, because you actually want to try to get it to stay in that form and hopefully cancel something. Now, if you look at the numerator, don't necessarily consider all three terms, but look for two of them. Are there two of them we know something about? And hopefully, yes, somebody out there is going, oh, look, the last two are cosine squared plus sine squared. Have we seen that somewhere before? And the answer would be yes. We know cosine squared plus sine squared is 1 plus cosine of x. Out front here. I couldn't cancel it. I didn't cancel the sine squared and the cosine squared. I used identity number 6 to say it was equal to 1. Okay, then I need sine times 1 plus cosine x. So, anybody notice anything here? What you can do? There's a slick thing that just happened. You have a cosine plus 1, and on the bottom you have a 1 plus cosine. If that's the case, aren't those exact same quantities? I could rewrite the numerator as 1 plus cosine. Wouldn't make a difference. But those are the exact same quantities, so you may cancel the whole quantity. You can't cancel individual terms that are added and subtracted, but you can cancel whole quantities. And so now you're left with 1 over sine or cosecant. Last but not least, I can't get my last problem done. It's going to be a matching problem, so I'm going to stop the video again.